show you just a little bit more advanced, just so that you can parameterize things and then call a function many times without really writing much more code. What we want to do is kind of whittle some of this down. I'm going to remove the IDN. Well, we can leave these here. But what I want to do is remove the second copy of these things, because what we're going to do, since we're repeating the same thing over and over, we can actually just call and change some variables. So first of all, let's delete those. So I've just pressed the delete key. So all we're going to do again is set a frequency, output it. So we're actually going to move that up, because we're going to turn the output on, and then we're going to, I guess it doesn't matter where it goes, but we have the system preset. I'm going to auto scale, do an OPC command, make sure everything's good, and then we're going to measure the frequency. But what we haven't done is made a parameter that we can pass something in. So if we go up here, we have a frequency that we can take data that comes in, and what we want to do is make that a parameter. So so it's giving us a warning saying parameters cannot contain units, therefore please specify the parameters value in the default value of Hertz units. So that's fine. I'm good with that. I'm going to update stage 11, and you see now the input parameters. This is our variable. We're going to input something called frequency, and the other one will be frequency 1, or that'll be our output. We can change that name actually to make it less confusing, I suppose. So let's just make that bigger. Frequency in, update there. That way it's a little bit more clear. So we're going to put frequency in 2 and frequency 1, which is our other variable down here. We've parameterized that. We're going to call that out, or we're going to call it measured. Well, let's leave it as frequency 1, because then we can just copy and paste some of our old code. We'll just leave that. So now we have pretty much a slightly, I guess, a whittled down version of it. We could probably remove some of these other checks. We can remove the OPT commands. That's just giving us options. We don't need that. The IDN, those are sanity checks. I probably would leave those in there just for debug purposes, so we won't streamline it too much. We could rearrange and not use auto scale every time, but again, those are things you can finesse in your own code later on. But what we're going to do now, when we export it, first of all, let's save our sequence, and then when we export it, what we're going to do is something a little bit different. So before, remember, we did generate it for an existing method. That's just one flat list. Well, what we're going to do is make a definition. So this is like a function call. So we can call this every time we want to do something. And when we call it with the value of frequency in, and we can pass back the returned value and then print that afterwards. And we can make a whole list of tests. So let's copy to clipboard. Let's go to this, and we're going to add a new file. I pre-tested this. You might already saw that on my screen, but so what we're going to do is call definition untitled. We could change that to measurement. We'll call that measurement. It's something you can come up with your own name if you like. And remember what I said in Python way back is that when you do a definition in a function, when you have white space like a tab at the beginning of a line, that means you're part of this function. So this colon and all this stuff that's offset is the function. Once we're back down here and we want to write code, our main code that would call this function, we need to step back and put it here. The other thing about Python is I believe, if I'm not mistaken, that your functions all have to go, or your definitions have to go at the top, because everything's read from top to bottom. If you put them afterwards, it may not be able to find the function. I don't know if people have programmed with BASIC in the past. You could stick your functions anywhere you wanted to. You can't do that with Python. You have to be very careful. There are other ways to call and import functions and put them in separate files, but I'm not going to go into that. So what we're going to do here is we're going to call this measurement, and the way we would do that is say measurement, and we're going to call it with a frequency in. Our argument is what frequency do we want to set the waveform generator for, and then what are we going to measure back? We're just going to set the same thing and read it back, but for this purpose, we're going to do we're going to do 2000, and we have to do it in hertz. Now, because we're returning frequency 1, we're returning this variable that's in here. We want to have something receive that variable. So what we're going to do is say measured value. We'll give that a variable. Measured value equals this. So when it calls this, measurement 2000 is going to be passed. This 2000 will be our frequency sent here, and wherever that variable is used, that'll be substituted. And at the very end, the returned value will be our variable here, measured value. Then we can print it. So then we could say print measured value. And that's it. You could say, well, let's just print that. We'll just print a straight list of them. We won't have any text around it. You can put some text. If you do want to put text with it, remember you got to say, put a string around it. Well, let's do that. Let's just do that. Say, we just measured value. I can't spell. Measured. My typing is not my forte, as you've noticed. Value plus, because we're sticking strings together, str. Measured value, and then even gives us a hint on what we should put next. String measured value. And if we've got everything typed correctly, if we had a mistake here, it would probably warn us. If I put measure value or something, it might say, I don't know what that is, or measured. Yeah, it's underlining it in red, giving us a warning. So that's nice. Code analysis, undefined name. So that's a good hint. So just something that's nice there. Now that we've entered it, now that error goes away. Let's test this out, and if that works, we can just copy those two lines and change the measurement, the frequency we're putting in. You know, if you want to parameterize this or make this even look test frequency, you could do this frequency equals 2, 1, 2, 3, 2000. That way, when we copy and paste this, it'll even be easier, and then we could even have forward while loops or different looping, so you can get really crazy with it. But that's better. The less you hard code numbers, the better. Your variables should come in later. It's just good practice, because then you can reuse the code much easier. So I'm going to say measure value, measurement. We're going to put the test frequency, print measured value. So I can just copy these three lines and just change this value, or I could make test frequency be a loop value or something like that. Anyway, we'll get to that in a second. What I'm going to do now, we'll keep our eye over here. I'm going to execute it. I'm going to save it. So let's call this testing many frequencies. And let's not leave white space here, because some parsers don't like that. Okay. Testing many frequencies.py. We're going to run it. Hopefully we won't get any errors. Okay. Well, we're going to test one frequency, then we're going to test more. So oh, there we go. Measured value equals 2000.19. I don't know what I was waiting for. I'm going to leave a space, make it look nice, put some arrow or something like that. Now, that's going to work. Well, why not just copy and paste this whole, so we can put just a star here, main, so that we know where we're kind of orient ourselves, and then do a couple of these. So let's do a couple of test frequencies. V, V, V. So this is where the power of automation comes in, when you have to do a bunch of different tests. Now, I'm just doing frequency in, frequency out, but you probably are going to do like a frequency in and then measure the voltage, the amplitude, because you might want to check a filter at different frequency levels and step through them. That can be a project you work on your own. But 2000, I'm going to go 3000, I'm going to do 4000. You can put anything you want in here. I'm just sticking with, I'm just putting these numbers in just because. We could make sure, we could just say don't auto scale the scope. We could go up and change the code. We could have different functions. There is a way to break out so that that resource is available and have a separate initialization file. I'm not going to show that here because that gets a little bit more advanced. It's okay to be verbose. I mean, when I'm writing code, I want to be able to read it and have somebody else that picks up my work down the road to be able to read it. Yes, it's a bit wordy, but it's extremely clear on what you're doing. And in my experience that I've had working for places that I've worked for in labs day in and day out, when you have to share amongst a group of people, it's better to be very clear so that there's no question, and then you can give them to your customers or whoever you're helping out. Makes it a lot easier. Let's run this. I'm going to go run, and here we go. So it's going to test each one of these frequencies. And again, we're doing frequency and frequency. We could have picked voltage, I guess, but again, that's something you can try out. So we got measured value. We got our first one here. Pretty cool. We should get another one. I'm expecting it's going to be around 3,000. Yeah, it is. It's going to be around 4,000. The next one. There's 4,000. And so forth. And you can do anything you want with these numbers. Now, there are ways to get the actual raw data points if you want to do really fancy file manipulation. It's probably much better to actually use the scope to do most of the heavy lifting of the measurements and the calculations for you. That way you're pulling less data across and you're using the scope, some of the internal resources for what they're meant for. So that's good. What else? Another good practice is there are ways to load the setup files for the scope. So maybe there is a complicated setup with a lot of stages, and you wanna load the setup file and then start making changes. You can do that too. The disadvantage to that is the file has to reside on the scope, and if you change scopes a lot, that's not so good. So it may be better to be verbose up here in your code. And remember, you want to make changes here. You can break things out, and then you create a library of things you want to work with. So again, hope this helps out. Again, this is the multi-instrument section. What you've done today is combine two instruments. You've simplified a bunch of complex measurements. You could make a table of 1,000 values and just have it run it over and over again, walk away, go have a coffee. You could run parallel systems and get a lot more work done trying different test scenarios. So the sky's the limit, and these are used for many, many things. So this is good skills to learn, can save a lot of time. And I've just scratched the surface just showing you how to get things going.